The red world grows larger in your small window, filling more of the view each day as your spacecraft crosses the final stretch of empty space between worlds. For months, this journey has continued, the distance shrinking slowly from millions of kilometers to hundreds of thousands, and now to mere thousands as Mars reaches out to meet you. The planet that appeared as a bright point of light in Earth's night sky has become a world with visible features: rust-colored deserts and white polar caps and the faint shadows of enormous canyons. What was once a destination has become a place, real and waiting, turning slowly beneath the approaching craft as the final hours of travel unfold. The approach reveals details that photographs could only suggest: the texture of a world becoming clearer with each passing hour of this long approach. Dust storms swirl in the southern hemisphere, visible as yellow-brown smudges against the darker terrain that lies beneath them and stretches for thousands of kilometers. The massive volcanoes of the Tharsis region catch the sunlight on their eastern slopes. 3 peaks in a line with Olympus Mons standing apart to the northwest. This is a world that has been waiting for billions of years, and now a small craft carrying human life is about to touch its ancient surface. You are listening to the Drowsy Astronaut, and tonight we are going somewhere extraordinary together, somewhere no human has stood before this moment. This is a slow journey, unhurried and calm, designed for late-night listening when the mind is ready to wander and rest, and perhaps drift into sleep. If this journey brings you some comfort during these hard times, wherever you are listening from, the like and subscribe options are there as an invitation to return whenever you need something vast and quietly fascinating to think about. For now, the red planet awaits, and we have all the time we need to explore it together in the hours ahead. The descent begins as the spacecraft separates from the cruise stage that carried it across the gulf between worlds for these many months of travel. Heat builds against the protective shield as the thin Martian atmosphere begins to push back against the falling craft with increasing resistance. The shield glows with the friction of entry, temperatures rising to over 1,000 degrees on the outer surface, while you remain protected inside the layers of insulation. Through the small window, the view is nothing but fire and plasma, and now the atmosphere is announcing your arrival with violence that will soon give way to calm. Your parachute deploys with a sharp jolt, the fabric catching the thin Martian air and slowing the descent from supersonic speeds to something more manageable for what comes next. Even fully opened, the parachute cannot slow the craft enough for a safe landing in this thin atmosphere that offers so little resistance to falling objects. The heat shield falls away below, tumbling toward the surface that now becomes visible for the first time through the cleared view. Red and brown terrain stretching to a curved horizon. Jezero Crater lies below, a circular basin 45 kilometers wide, where an ancient lake once held water deeper than many lakes on Earth. The final descent uses rockets to slow the last meters of falling, engines firing downward and kicking up dust that billows in all directions across the ancient ground. The landing legs touch down with a gentle bump, absorbing the impact, and then everything becomes very still as the engines shut down and the dust begins to settle. The sounds of the spacecraft fade to silence, The ventilation fans the only noise remaining inside the cabin, and through the window, the Martian surface waits. You have arrived on Mars, and for a long moment, there is nothing to do but look out at the rust-colored world beyond the glass. The dust that the landing rockets disturbed drifts slowly back toward the ground, falling more gently than dust would fall on Earth because of the lower gravity here. Each particle catches the salmon-pink light of the Martian sky as it descends, a curtain of suspended material gradually thinning to reveal the landscape beyond with increasing clarity. The terrain is flat here in the crater basin, scattered rocks of various sizes resting on soil the color of cinnamon and rust, mixed together into one ancient shade. This is Jezero Crater, the same place where the Perseverance rover has been exploring since February of 2021, now seen through human eyes for the first time. The silence is the first thing that truly announces you are somewhere else, a silence more complete than any place on Earth can offer to visitors. On Earth, even the quietest locations have atmospheric sounds: wind through leaves, distant thunder, the rustle of air moving across the ground and carrying faint noises from far away. Here the atmosphere is so thin that sound barely travels at all. And outside the spacecraft, there would be near perfect silence, even if wind was blowing across the surface. Inside the cabin, you hear only the soft hum of life support systems, the gentle circulation of air keeping you alive, where unprotected humans would survive only seconds. The first step outside requires careful preparation, checking the suit systems that will become your entire world whenever you leave the shelter of the spacecraft in coming days. The suit maintains pressure, provides oxygen, regulates temperature, and protects against radiation that the thin Martian atmosphere does little to block from reaching the surface. Each seal is verified, each system tested, each backup confirmed ready in case the primary systems encounter problems during surface activity outside the craft. The airlock cycles slowly, pressure dropping to match the near vacuum outside. And then the outer hatch opens onto a world no human foot has ever touched. The ladder extends downward, a short climb in the weak gravity that pulls with only 38% of the force your body learned to expect on Earth during every moment of life. Each rung feels different, your suited body lighter and slower to respond, the movements requiring recalibration that your muscles will learn over the coming days of activity. The final rung gives way to the surface itself, and you step down onto soil that has waited for this moment through the entire history of life on Earth and before. The footprint that forms in the dust is the first human mark on Mars, an impression that will remain unchanged for years in this world without rain or flowing water. Standing on the surface, the landscape reveals itself with a clarity that no photograph could fully capture or convey to viewers on distant Earth. The horizon curves more sharply than you are accustomed to seeing, Mars being only half the diameter of Earth, and therefore wrapping its surface more tightly around its smaller volume. The crater rim rises in the distance, perhaps 15 kilometers away to the east, a low wall of hills defining the edge of this ancient basin where you now stand. Between here and there, the terrain is remarkably flat, scattered with rocks that range from pebbles to boulders, all of them resting undisturbed on ground that has not changed significantly in millions of years. The color of the surface is more varied than photographs suggested. Not simply red, but a complex palette of rust and brown and tan and darker patches, almost grey in tone. The dust that covers most surfaces is fine, finer than beach sand, more like the texture of talcum powder or cocoa dusted across everything visible in the landscape. Beneath the dust, rocks of various types are visible: dark basalts from ancient volcanic flows, lighter sedimentary stones deposited by the water that once filled this crater long ago. Each rock tells a piece of the story of this world, a story written over billions of years and now readable by the first human visitors to examine it up close. The sky above is unlike any sky you have known. A soft salmon pink that fades to butterscotch near the horizon, where dust thickens the view toward distant terrain. The sun appears smaller here, noticeably so, about 2/3 the size it presents when viewed from Earth's surface, because of the greater distance separating Mars from our shared star. The light has a different quality, slightly dimmer, slightly cooler in color temperature, casting shadows that seem softer than Earth shadows, despite the thin atmosphere that should sharpen rather than soften them. This is afternoon light on Mars. The sun passed its highest point, beginning the long, slow descent toward a sunset that will paint the sky in unexpected colors. Looking back at the spacecraft, the landing site appears small against the vastness of the crater floor that extends in all directions, without limit, visible to the eye. The vehicle stands on its landing legs, dust already beginning to accumulate on the surfaces that the descent engines had briefly cleaned, the red world reclaiming everything touched by this visitor. Supply containers are stacked nearby, equipment that was landed in previous robotic missions preparing for this moment, when humans would finally arrive to use them. The base you are here to establish will grow from this point, this specific location, becoming the first permanent human presence on another world in all of history. The temperature reading on your suit display shows -53 degrees Celsius, though you feel nothing but the comfortable warmth maintained by the suit systems against your skin. This is relatively warm for Mars, a midday temperature in a favorable location during a favorable season, and temperatures will drop dramatically as night approaches in the hours ahead. The suit compensates without difficulty, heating elements ready to maintain body temperature through the long Martian night when surface temperatures can drop below -80 degrees or colder still. You are protected, comfortable, able to focus on the world around you rather than the hostile conditions that would otherwise make this experience impossible. The ground beneath your boots has not been disturbed by any living creature for over 3 billion years, since the last of the surface water vanished, and whatever life may have existed here fell silent forever. Each step you take writes new history in the dust, marks that will remain visible for decades, unless future visitors disturb them or dust storms eventually fill them in. The rocks you pass have sat in these positions for millions of years, moved only by the rare impacts of smaller meteorites that occasionally strike the surface across geological time. This is a world where time passes differently, where change happens so slowly that human lifetimes are mere instants against the patient endurance of the landscape. In the direction of the crater wall, a formation rises from the floor of the basin, a layered structure that represents your first destination for exploration beyond the landing site area. This is the ancient river delta, a fan-shaped pile of sediment deposited billions of years ago when a river flowed through a gap in the crater rim and entered the lake that filled this basin. The delta has been studied by Perseverance, samples collected for eventual return to Earth, but seeing it with human eyes adds a dimension that robotic cameras cannot quite convey to distant viewers. Tomorrow, you will walk toward that structure, but for now, the immediate surroundings require attention, and the first steps of this mission are enough for these initial hours. The spacecraft will serve as home base during these early days, while the permanent shelter is constructed at the site you have been sent here to establish for future inhabitants. Inside, the pressurized cabin offers a small space where the helmet can be removed, where food can be eaten, where sleep can happen in something approaching normal conditions for a human body. The airlock cycles again as you return from the first surface walk, pressure rising to match the interior, the outer door sealing against the thin atmosphere that would kill you in moments if left exposed. Inside, the familiar sounds of life support surround you, and through the window the red world waits, patient as it has always been, ready for whatever comes next. The morning arrives slowly on Mars, the sky lightening from black to deep purple, to the familiar salmon pink as the sun climbs toward the horizon from below. Sleep came eventually, despite the strangeness of the surroundings, the body demanding rest after the intensity of landing and the first surface walk outside the craft. Through the small window of the spacecraft, the terrain looks different in the dawn light, shadows stretching westward now instead of eastward, the same rocks and dust presenting a new face to the day. Today, the first real exploration begins, a walk toward the river delta, visible in the distance, where the evidence of ancient water lies exposed in layered cliffs. The suit checks have become more familiar already, the sequence of verifications that ensure everything will function properly during the hours outside in the cold, thin air. Each joint moves smoothly. Each seal holds pressure. Each system reports nominal status on the display inside the helmet. That will be your window to this world today. The airlock cycles with its patient rhythm, pressure dropping gradually until the outer hatch can swing open without resistance from the atmosphere that no longer pushes back. Outside, the morning air is colder than yesterday afternoon. The temperature reading showing -71 degrees as the night's chill still lingers across the ancient ground. The walk toward the delta begins at an easy pace, each step covering slightly more ground than it would on Earth because of the lower gravity that lets you bounce gently forward. The terrain varies between patches of smooth dust and fields of small rocks that require attention to avoid stumbling on the uneven surface beneath your boots. The delta grows larger with each 100 meters of progress, its layered face becoming more distinct. The horizontal lines of ancient sediment emerging from what appeared as a uniform slope from further away. This formation represents millions of years of history, each layer a chapter in the story of a time when Mars was warm and wet enough for rivers to flow. The distance is perhaps 3 kilometers from the landing site to the base of the delta structure, where the exposed cliffs begin their rise toward the top. 3 kilometers is not far, an easy walk on Earth that would take perhaps 40 minutes at a relaxed pace without hurry or difficulty. Here, the walk takes longer, partly because of the suit that restricts movement despite its flexible design, and partly because there is so much to observe along the way across the crater floor. Each rock passed is a potential sample, each variation in the soil color a clue to what lies beneath, each feature a piece of the puzzle that scientists on Earth are waiting to understand better. The rover tracks from Perseverance are occasionally visible, the wheels having left impressions in the dust that remain undisturbed years after the robot passed through this area. The rover explored these same terrains, examined these same rocks, sent images of these same vistas back to Earth, where they were studied by scientists who could only imagine what standing here would feel like directly. Now you walk parallel to those tracks, in places a human following the path that a machine blazed through this ancient wilderness, carefully and slowly over many months. The rover is still operating somewhere to the north, continuing its work, unaware that the first human visitors have arrived in the area it helped explore. The delta cliff face comes into clear view as the final stretch of the walk brings you to the base of the formation that rises steeply ahead. The layers are distinct, even from a distance, alternating bands of lighter and darker material, stacked horizontally in a pattern that speaks clearly of deposition over long periods of time. Up close, the texture becomes visible. Some layers smooth and fine-grained, others rough and pebbly, some containing rounded stones that were clearly transported by flowing water before coming to rest here. This is not interpretation or theory, but direct observation of evidence, written in stone by processes that operated billions of years before any life existed on Earth. The lowest layers of the delta formed first, deposited when the river first began flowing into the ancient lake that filled Jezero Crater during the wet period of Martian history. Water carried sediment from the highlands beyond the crater rim, fine particles suspended in the flow. Heavier pebbles rolled along the river bottom until the current slowed where the river met the standing water of the lake. As the current slowed, the sediment dropped out, the heaviest particles first and the finest particles last, building layers that reflect the varying conditions of each flood and each drought over thousands of years. The result is this formation, a frozen record of a hydrological cycle that ceased operating before complex life appeared anywhere in the solar system. Running your gloved hand along the cliff face, you can feel the texture of the layers through the pressure of contact, even though the glove prevents direct touch of the ancient stone. Some layers crumble slightly under pressure, material weakened by billions of years of exposure to temperature cycles and the faint moisture that occasionally condenses from the thin atmosphere in traces. Other layers are harder, more resistant, perhaps cemented by minerals that precipitated from the water that once saturated these sediments during the wet time long ago. Each layer tells a slightly different story, and together they narrate the history of a world that was once far more hospitable than the cold desert it has become. The colors in the cliff face vary more than the surface dust suggests. The deeper layers protected from the iron oxide dust that coats everything exposed to the Martian winds. Some layers are grey, similar to mudstones found on Earth in ancient lakebeds, where clay particles settled in quiet water over centuries. Other layers have a greenish tint, suggesting the presence of minerals that form only under specific chemical conditions that scientists are still working to understand completely from remote data. The variety speaks to changing conditions over time. Different episodes of the lake's history leaving different signatures in the sediments that accumulated on its floor. Looking up at the full height of the delta exposure, the scale becomes impressive in a way that photographs could not fully convey to distant viewers. The cliff rises perhaps 60 meters above the crater floor here, layer upon layer of ancient history stacked like pages in an enormous book that records millions of years of Martian time. Somewhere in these layers, there may be evidence of life. Organic molecules preserved in sediments that were deposited when conditions on Mars might have supported biology similar to Earth's earliest organisms. The samples that Perseverance collected from these layers are waiting in sealed tubes for future retrieval, eventual transport to Earth, and analysis that may answer questions humanity has asked for generations. The search for life in these rocks is not based on hoping for fossils of complex creatures that walked or swam in the ancient lake during the wet period. Instead, scientists look for chemical signatures, patterns of carbon isotopes, molecular structures, mineral formations that only occur when biology is present, to create them through metabolic processes. On Earth, rocks from similar environments preserve these signatures for billions of years, and there is no reason Mars should be different. If life ever existed here in the ancient past, the absence of plate tectonics on Mars means these rocks have not been recycled through the mantle, not transformed by heat and pressure, potentially preserving pristine records of whatever existed here when water flowed. The river that built this delta entered the crater through a gap in the rim to the north, a channel carved by flowing water that is still visible in orbital images despite billions of years of erosion softening its edges. Standing here at the base of the delta, you can trace the direction of flow, understand how the sediment accumulated, visualize the landscape as it once appeared when the lake spread across the crater floor. The water level rose and fell over time, the delta building outward during wet periods, exposed during dry periods, when the lake shrank or vanished entirely for intervals measured in thousands of years. Eventually, the water stopped coming altogether, and the delta became a fossil of itself, a monument to conditions that would never return. Walking along the base of the cliff, new features come into view with each 100 meters of progress along the formation that extends for several kilometers. Here, a section of the cliff has collapsed, revealing layers that were previously hidden. Fresh exposures where samples could be collected without the contamination of surface weathering that might compromise results. There, a cave-like overhang has formed, where softer layers eroded faster than the harder cap rock above, creating a shelter where dust accumulates in wind-blown drifts. The formation is not uniform but varied, each section presenting new details for examination by the first human eyes to see them at this close range. The time passes without hurry as the exploration continues along the delta face, each discovery leading to the next in natural progression through the ancient landscape. The sun climbs higher in the pink sky, the temperature rising toward the afternoon maximum that will still be far below freezing by Earth standards. The suit maintains comfort without apparent effort, the life support systems handling the thermal regulation, while you focus entirely on the remarkable world surrounding you on all sides. This is what exploration feels like when there is no schedule pressing, no deadline approaching, just the slow accumulation of experience in a place that has waited billions of years for this moment. A section of the cliff contains what appear to be cross-bedded layers, sediment deposited not horizontally but at angles that indicate flowing water rather than still water settling from above. These structures form in rivers, where current pushes sediment over ledges, building sloping deposits that eventually become buried and preserved as angled layers within the broader horizontal sequence. On Earth, geologists read these structures like words in a sentence, extracting information about current direction, flow velocity, water depth, and seasonal variations in river discharge from long-vanished systems. Here on Mars, the same story can be read, the same physics having operated the same way, despite the billions of kilometers and billions of years separating these rocks from any Earth equivalent. The afternoon wears on, and the return walk to the spacecraft begins as the sun descends toward the western horizon, where it will set in colors unlike any Earth sunset visible. The delta remains behind, unexplored sections waiting for future visits. Over the coming days, when more of its secrets will be revealed through careful examination and observation. The footprints, leading away from the formation, join the footprints leading toward it, a trail now established between the landing site and this first explored feature that will be walked many times before the mission concludes. Each step covers ground that no human had covered that morning, and by evening, the first loop of human exploration on Mars will be complete. The landing site comes back into view as the final kilometer of the walk unfolds across the familiar terrain near the spacecraft that represents safety and shelter in this harsh environment. The craft looks smaller than it did yesterday, perspective having shifted as the scale of the crater becomes more familiar to eyes that are learning to read this landscape without effort. Equipment containers await attention. Tasks for tomorrow, including the establishment of the base that is the primary mission objective, driving this entire enterprise forward. Tonight, there will be rest, and through the window the stars will appear in a sky that shares the same constellations but sits above a very different world than any human has called home. The sky above demands attention now that the immediate terrain has become more familiar through yesterday's exploration of the delta and its surroundings. Looking up from anywhere on the Martian surface, the first thing that strikes you is the color. Not blue, but a soft salmon pink that deepens to butterscotch near the horizon where dust thickens the atmosphere. This color is not merely aesthetic, but the result of iron oxide particles suspended throughout the thin atmosphere, scattering light in patterns opposite to what Earth's nitrogen and oxygen produce back home. On Earth, shorter blue wavelengths scatter most, painting our sky the color we consider natural. Here, the fine reddish dust scatters longer wavelengths preferentially, creating this eternal pink-orange canopy. The atmosphere you look up through is extraordinarily thin, containing less than 1% of the air pressure that pushes against everything on Earth's surface at sea level. If you could remove your suit and take a breath here, the result would be rapidly fatal. Not only because the air is unbreathable carbon dioxide, but because the low pressure would cause your bodily fluids to boil at body temperature almost immediately. The atmosphere is there, visible in its color and its dust, but it offers almost none of the protection that Earth's thick blanket provides against radiation, temperature extremes, and the vacuum of space beyond. This pink sky is beautiful, but it is not friendly to life as we know it. The composition of this thin atmosphere is predominantly carbon dioxide, about 95% of the total, with small amounts of nitrogen, argon, and trace gases making up the remainder in much smaller proportions. On Earth, carbon dioxide is a trace gas, less than 1% of our atmosphere. Yet here, it dominates completely, without providing the warmth that greenhouse gases create on our home planet. The atmosphere is simply too thin for the greenhouse effect to operate strongly. And what warming does occur is not enough to raise temperatures above freezing, except in the warmest conditions, at specific locations. Mars breathes carbon dioxide, but shivers in cold that reaches extremes rarely experienced even in Antarctica's darkest winter. The dust that colors the sky is remarkably fine, particles averaging about 1.5 micrometers in diameter, smaller than the width of a human hair by a factor of 50 or more. This dust rises into the atmosphere through wind action, dust devils that form when the surface heats unevenly, and the massive dust storms that occasionally grow to engulf the entire planet in a haze lasting months at a time. Once aloft, the particles settle slowly in the low gravity, remaining suspended far longer than similar particles would in Earth's denser atmosphere before falling back to the surface. The sky is never truly clear on Mars, always holding some burden of dust that colors the light and softens distant views. Sound behaves strangely in this thin atmosphere, traveling poorly compared to Earth, where air molecules are packed closely enough to transmit vibrations efficiently across long distances and through open spaces. The Perseverance rover carries a microphone that recorded the first sounds ever captured on the Martian surface. And those recordings reveal a world of muted, distant-seeming noises, even for nearby sources. Wind that would howl on Earth barely whispers here, and impacts that would crack and boom produce soft thuds that fade quickly, without carrying far from their source location. If you could hear outside your helmet, the world would seem strangely hushed, events happening in near silence, despite the motion visible all around. The wind that does blow across this world can still move things despite the thin atmosphere offering little force against surfaces exposed to it. Dust migrates constantly across the surface, building dunes and drifts, filling craters, and slowly eroding exposed rocks over millions of years of persistent gentle abrasion against everything standing in its path. The patterns left by wind are visible everywhere. Ripples in the dust, streamlined shapes behind obstacles, the smooth polish on rocks, facing the prevailing wind direction that brings particles against their surfaces continuously. The wind cannot lift heavy objects as earth wind can, but given enough time, it reshapes everything, patient as the slow rotation of the planet itself. Looking toward the horizon, the atmosphere creates visible layers of color, the sky darkening toward pink overhead and lightening toward peachy orange near the ground, where your line of sight passes through more dust-laden air. The distance you can see clearly varies with atmospheric conditions, sometimes extending for many kilometers to the crater rim and beyond, sometimes closing in as suspended dust thickens the view to near opacity during storm conditions. Today, the air is relatively clear, the crater rim visible as a distinct line against the colored sky, details on distant slopes discernible with careful attention to what lies far across the basin floor. This is a good day for observation, a clear day by Martian standards. The sun crosses this strange sky on a path similar to Earth's sun, because the axial tilt of Mars is remarkably close to our planet's inclination relative to its orbital plane around the shared star. Seasons exist here as they do on Earth, summer and winter, spring and fall, created by the same mechanism of tilted axis, presenting different hemispheres toward the Sun at different points in the orbital year. The Martian year is nearly twice as long as Earth's, meaning seasons last nearly twice as long as well, winters stretching for many Earth months of cold and darkness at the poles. From this location in Jezero Crater, the seasonal changes are more subtle, temperature variations less extreme than at higher latitudes where ice grows and shrinks dramatically. As the afternoon progresses, the Sun begins its descent toward the western horizon. And here is where Mars presents its most surprising visual phenomenon to observers watching carefully. On Earth, sunsets paint the sky in oranges and reds as light passes through more atmosphere on its slanted path toward the horizon, scattering away blue light first. On Mars, the opposite occurs. The fine iron oxide dust scatters red light forward toward the observer, while allowing blue light to reach the eye from the direction of the setting sun itself. The result is a blue sunset, the sky around the descending sun taking on a pale blue-grey color that seems impossible to eyes trained by a lifetime of Earth's orange evenings. The blue glow begins subtly, a lightening of the pink near the sun as afternoon fades toward evening and the sun drops lower in the western sky. As the sun approaches the horizon, the blue becomes more pronounced. A cone of steel blue light spreading outward from the small bright disk that is noticeably smaller than Earth's sun appears from home. The surrounding sky remains pink and orange, creating a contrast that feels deeply alien, a reversal of everything the eye expects from a sunset on any world orbiting this same star. The blue lingers after the sun disappears below the horizon, gradually fading as darkness rises from the east and claims the sky for night. The twilight period extends longer than it would on Earth, light scattered by dust, continuing to illuminate the sky well after the sun has dropped below the visible horizon line in the distance. This extended glow provides a gradual transition from day to night, the pink sky deepening through purple toward black. Over the course of perhaps an hour, depending on atmospheric dust levels present. During this time, the brightest stars begin to appear, points of light emerging against the darkening backdrop. Familiar patterns from Earth's night sky, because the constellations look the same from anywhere in the inner solar system. The stars seem steadier here, less twinkling, because the thin atmosphere produces less of the turbulence that makes stars shimmer when viewed from Earth's surface. The full darkness of Martian night reveals a sky of extraordinary clarity once the twilight has faded completely from the western horizon and only stars remain. Without city lights, without aircraft, without the atmospheric distortion that Earth's thick air creates, the stars appear sharp and steady, like points of pure light pinned against absolute black. The Milky Way stretches across the sky with a clarity that only the most remote Earth locations can match. Its cloudy band of countless distant stars, visible as a distinct feature rather than a subtle glow, easily missed. This is the universe as it appears from a world that does not obscure the view, a front row seat to the cosmos. Dust devils form occasionally during the warmer parts of the Martian day, visible as spinning columns of pink-brown material rising from the surface, where uneven heating creates rotating air currents that climb upward and carry dust along with them. These vortices can reach hundreds of meters in height, visible from many kilometers away as they drift across the landscape, following no predictable path through the afternoon hours. Unlike Earth tornadoes, they pose little danger to equipment or personnel. because the thin atmosphere means they carry very little force, despite their impressive visual appearance against the colored sky. They are ghosts more than threats, visible motion in a world that otherwise appears completely still to observers watching the landscape. Occasionally, larger dust storms form, beginning as regional events that may grow to planetary scale if conditions favor their expansion across the entire globe simultaneously. The global dust storm of 2018 grew so thick that it blocked enough sunlight to end the Opportunity rover's mission after 15 years of operation relying on solar power for survival. For humans on the surface, such a storm would present challenges: reduced solar power collection, limited visibility, dust infiltration into equipment and habitats, despite best filtration efforts available. The storms pass eventually, dust settling out of the atmosphere over weeks or months. But while they last, they transform Mars into a featureless orange globe, visible from orbit only as a uniform sphere without surface details. The sky tells time on Mars as it does on Earth, the sun's position marking the hours of the sol, the stars wheeling overhead during the night following patterns familiar from any astronomy learned back home. The slightly longer Martian day means this rhythm gradually shifts relative to Earth time. Mission control schedules drifting out of alignment with local conditions over weeks of surface operations. The body adjusts to the longer day without too much difficulty. The extra 37 minutes distributed across waking and sleeping in ways that barely register consciously. The sky becomes a clock, the horizon a calendar, and the rhythm of light and dark a structure that shapes each soul's activities and rest. The full cycle of a Martian day becomes familiar through lived experience rather than reading or description. The body learning what the mind already understood as the first complete soul unfolds on the surface. Morning begins in darkness, the sky still black with stars, when the first faint glow appears along the eastern horizon, marking the approach of sunrise, still an hour away. The transition from night to day happens gradually, the black sky fading to deep purple, then to pink, then to the full salmon color of Martian daylight as the sun climbs towards visibility. This progression takes longer than Earth's sunrise, the thin atmosphere scattering light across a wider range of time as the geometry slowly changes. The temperature rises with the light, though the relationship is not as direct as it feels on Earth, where sunrise brings noticeable warming within minutes of the sun appearing above the horizon line. Here, the ground has cooled dramatically overnight, absorbing the sun's heat slowly through the morning hours, before temperatures begin to climb noticeably on the displays inside your helmet. By mid-morning, the temperature might have risen 40 degrees from the overnight low, still far below freezing but trending toward the relative warmth of afternoon, when the sun reaches its highest point. The lag between light and heat is a reminder that this thin atmosphere holds almost no warmth, contributing nothing to the temperature regulation that Earth's thick air provides. The sun reaches its highest point around midday, though even at its peak it appears smaller than the sun viewed from Earth. A slightly diminished disk crossing a sky that does not match the blue we associate with sunny days back home. The shadows at midday are shortest, nearly vanishing for objects standing straight up from the surface. And the light is most intense during these hours, centered around noon. This is the best time for activities requiring good visibility, the worst time for activities requiring cool temperatures, and the time when solar panels collect their maximum power for the day's energy needs. The sun lingers near its highest point for a while, before beginning the afternoon descent that will end in the blue-tinged sunset, visible later. Afternoon stretches across many hours as the sun traces its slow path toward the western horizon, shadows lengthening, temperatures peaking, and then beginning to fall as evening approaches. The quality of light changes during these hours, becoming more golden, more angled, casting longer shadows that reveal surface textures invisible during the harsh light of midday directly overhead. Photographers on Earth call these the golden hours, and the same principle applies here, even though the gold is mixed with the ambient pink of the Martian atmosphere's scattered light. This is a contemplative time of day, the harsh brightness of midday softening, the landscape becoming more dimensional as shadows define the shapes of rocks and formations. The evening transition begins as the sun approaches the horizon. The blue sunset phenomenon gradually emerging as described before, painting the western sky in colors that reverse Earth's familiar palette. The temperature drops quickly once the sun sets, the thin atmosphere providing almost no insulation to retain the day's accumulated warmth against the cold of space, waiting just above. Within an hour of sunset, temperatures can fall 20 degrees or more, the ground radiating heat into the dark sky without any atmospheric blanket to slow the cooling process happening everywhere simultaneously. Night arrives not gently but with purpose, claiming the warmth and leaving cold in its wake across the entire visible landscape. The night hours on Mars last about as long as Earth nights at similar latitudes, the slightly longer Sol distributing additional time across both day and night portions of the cycle evenly. During these hours, the temperature continues to fall, reaching minimum values in the hours just before dawn, when the ground has radiated away as much heat as it will lose before the sun returns. The overnight low can be 50 or 60 degrees colder than the afternoon high, a swing that would be extraordinary on Earth, but is routine here where nothing moderates these extremes effectively. The suit handles this variation without difficulty, but exposed equipment must be designed to survive these cycles, repeated every single sol indefinitely. Sleep comes during these cold, dark hours, the body following the rhythm of light, even on a world where the schedule differs slightly from the one evolution programmed into human biology over millions of years on Earth. The 37 extra minutes each sol accumulate over time, shifting the relationship between local conditions and body clock expectations. But the adjustment is manageable for most people without severe disruption to sleep or function. Mission planners learned from decades of rover operations that Mars time is livable for humans, even if the gradual drift relative to Earth time complicates communication schedules with controllers back home. You sleep, and outside the thin walls of the spacecraft, the temperature drops toward its nightly minimum as stars wheel overhead. The pre-dawn hours bring the coldest temperatures and the darkest skies of the entire sol, the time when the ground has lost the most heat and the sun is furthest below the horizon. The stars shine steadiest during these hours, the absence of any atmospheric warming reducing turbulence to its minimum and presenting the clearest views of the universe available from this location. If you wake during these hours and look through the window, the world outside appears almost lunar in its stillness, a frozen landscape waiting for the light that will eventually return from the east. The cold is patient, indifferent, as much a feature of this world as the rocks and dust that define its visible character. The approach of dawn reverses the evening sequence, the eastern sky lightening first to purple, then to pink, then to full daylight as the sun climbs from below the horizon towards visibility. This second sunrise you witness carries less novelty than the first, but no less beauty. The colors still strange enough to capture attention despite the growing familiarity with Martian conditions. After a full sol of experience, the temperature begins to climb again, the daily cycle resetting, the pattern that will repeat throughout your stay on this world established now, through direct personal observation and embodied experience. This is the rhythm of Mars, the pulse of a world that has followed this pattern for billions of years. The sol, as a unit of time, becomes natural to your thinking surprisingly quickly. The slightly longer day incorporating itself into planning and activity without conscious effort. After the initial adjustment period passes, tomorrow and yesterday mean sol lengths now, distances measured in how many sols of travel they would require, work estimated in sols rather than days for the duration of this mission on the surface. The body adjusts, the mind adjusts, and what seemed strange becomes routine through the simple process of living it directly and continuously. Mars keeps its own time, and visitors learn to keep it too, or else struggle against a rhythm that cannot be changed by human preference or expectation. The two moons of Mars add complexity to the night sky, particularly Phobos, which moves so fast in its close orbit that it rises and sets multiple times during a single night if you watch for it consistently. This small, irregularly shaped moon crosses from west to east in a few hours, its motion visible against the background stars, even without prolonged observation carefully tracking its position over time. Deimos moves more slowly, a dimmer object that takes more than a full sol to cross the sky, appearing more like a bright wandering star than a moon in the traditional sense that Earth's companion represents. Together, they trace patterns that no Earth observer has ever seen, except through the eyes of cameras sent across the void to witness them firsthand. The rhythm of the sol structures all activity during the mission, from the scheduling of surface walks during favorable thermal conditions to the timing of communication windows with Earth when orbital geometry permits signal transmission efficiently. Meals happen, sleep happens, work happens, rest happens, all organized around the light and temperature cycles that define this world's temporal character from the surface observer's perspective. The structure feels natural once established, a framework that the body accepts and the mind uses without resistance or resentment at its slight difference from Earth normal. Living on Mars time is simply living, adapted to a world that did not adapt to human expectations, but offers its own patterns instead. The changing angle of sunlight through the sol reveals different aspects of the landscape at different hours. Morning light from the east, illuminating the western faces of formations, while afternoon light reverses this relationship entirely. The delta cliffs that appeared one way yesterday appeared differently today when visited at a different hour. Shadows falling in new directions, colors shifting in response to the changed illumination angle, presenting them for observation. This is one reason surface operations continue over multiple sols, rather than rushing to see everything once. The same features reward repeated visits as conditions change through the daily cycle. Patience reveals what haste would miss, a principle that applies to exploration as surely as it applies to any careful work undertaken thoughtfully. The night sky on Mars reveals companions that Earth's single moon cannot offer. Two small irregular bodies tracing paths that differ completely from each other and from any moon behavior familiar from home. Phobos is the larger and closer of the two, orbiting so near to the Martian surface that it completes 3 trips around the planet, while Mars rotates just once beneath it in the same time period. This means Phobos rises in the west and sets in the east, the opposite direction from everything else in the sky, racing across the darkness in a few hours, while the stars crawl slowly in the normal direction behind it. The sight is strange enough to capture attention every time it occurs. A moon moving wrong against every instinct, trained by a lifetime under different skies. The appearance of Phobos differs dramatically from Earth's moon. Its shape clearly irregular, even to the naked eye. A lumpy, potato-like object, rather than the smooth disk we associate with moons, seen from planetary surfaces. At its closest approach overhead, Phobos appears about 1/3 the angular width of Earth's moon, as seen from home, large enough to show some detail, but small enough to appear more like a bright object than a world in its own right. The surface is dark, heavily cratered, dominated by the massive Stickney crater that spans nearly 1/3 of the moon's entire diameter, visible on the approaching face. This is not a world in itself, but a captured asteroid, a piece of cosmic debris that fell into orbit around Mars billions of years ago and has been slowly spiraling inward ever since. The speed of Phobos across the sky makes it possible to watch its motion in real time without the patience required to observe most astronomical movements directly. Standing on the surface during a pass, you can see the moon's position change against the background stars over the span of minutes, tracking across the sky at a rate visible to attentive observation without instruments. The motion feels faster than seems natural for something so apparently distant, a reminder that orbital mechanics scale differently at different distances, and this moon is remarkably close to the surface beneath your feet. In about 50 million years, Phobos will either crash into Mars or break apart from tidal stresses. But for now, it continues its fast circuits above the world that captured it. Deimos is the smaller and more distant of the two moons, orbiting at about 23,000 kilometers above the surface, compared to Phobos's mere 6,000 kilometer altitude above the landscape. From this greater distance, Deimos moves slowly enough that it takes more than 2 full sols to cross the sky from horizon to horizon, creeping eastward at a pace barely perceptible without careful tracking over extended periods. The object itself appears only as a very bright star, too small and too far to show any disk or shape to the naked eye from the surface below its distant orbit. Unlike Phobos, Deimos rises in the east and sets in the west, like the stars behind it, its orbital period longer than the Martian day by a margin that keeps it moving in the expected direction. Both moons are captured asteroids, objects that formed elsewhere in the solar system and were swept up by Mars's gravity during close passes, millions or billions of years ago, when circumstances aligned to permit their capture. Their compositions are similar to certain types of asteroids found in the outer reaches of the asteroid belt. Dark, carbonaceous material that reflects little light and appears grey or slightly reddish under close observation by spacecraft that have visited them. Neither moon is large enough to pull itself into a spherical shape through self-gravity. instead retaining the irregular forms they had when they fell into Martian orbit and began their long residence as the planet's small companions. They are moons by orbital circumstance, rather than by any inherent quality of moonness in their natures. The eclipses that Phobos causes are unlike any solar eclipse visible from Earth, more like transits than true eclipses, because the moon is too small and too close to cover the sun completely during its passages. When Phobos crosses the sun's face, it appears as a dark, irregular shape, moving quickly across the bright disk, taking only about 30 seconds to complete the transit from one edge to the other. The sky does not darken significantly during these events because Phobos covers only a fraction of the sun's surface area at any moment during the crossing. Perseverance has filmed these transits, revealing the potato-shaped silhouette of Phobos against the sun's glow in some of the most striking imagery returned from the Martian surface. The rest of the night sky is more familiar, the constellations appearing essentially identical to their appearance from Earth, because the relatively small distance between the planets makes no difference to stars located many light years away from both. Vantage points. Orion rises in the east as winter approaches in the northern hemisphere. The same three belt stars and the same red shoulder of Betelgeuse, visible to observers on Earth watching the same sky from an unimaginably different surface. The Big Dipper wheels around the North Celestial Pole, though here the pole itself sits in a slightly different location because Mars's axis points differently than Earth's axis, despite the similar tilt angles. The familiarity is comforting, a reminder that this is the same universe, the same neighborhood, just a different porch from which to view it. Earth is visible in the Martian night sky, appearing as a bright, blue-white point of light that stands out clearly from the reddish or white hues of most stars surrounding it in the sky. The color is the giveaway, that distinct blue tint that no star mimics closely, betraying the presence of an atmosphere rich in nitrogen and water that scatters light in the particular way that makes Earth Earth from any distance at which it remains visible. At times, with good conditions and careful observation, the moon can be seen as a separate point of light, very close to Earth. The pair appearing as a close double that separates only when both are positioned correctly relative to your line of sight from Mars. Everyone you have ever known lives on that small blue point, going about their days and nights, unaware of your observation from across the gulf of space, separating the two worlds. The distance to Earth varies considerably, depending on where both planets are in their respective orbits around the Sun at any given time during the Martian year. At closest approach, Earth is about 55 million kilometers from Mars, a distance light crosses in about 3 minutes, traveling at its universal maximum speed. At farthest separation, the distance stretches to over 400 million kilometers, light taking more than 20 minutes to make the journey between the two worlds through empty space. Communication with Earth reflects this reality. Messages sent home arrive after delays measured in minutes, and responses take equally long to return, making conversation impossible and requiring patient exchange of information packets instead. The stars seem steadier from Mars than from Earth, their light twinkling less because the thin atmosphere produces less of the turbulence that causes stellar scintillation when viewed from beneath thicker air. This steadiness makes observation easier and more pleasant, the points of light sitting still in their positions rather than dancing and flickering as they do through Earth's churning atmosphere. on even clear nights. Astronomers on Earth dream of such stability, building telescopes on mountain tops, and eventually in space to escape the atmospheric interference that plagues ground-based observation from sea level. Here on Mars, the sky itself provides what Earth's atmosphere denies to observers seeking clear views of the universe. The Milky Way stretches across the Martian night sky with a clarity that matches only the most remote and light pollution-free locations on Earth today, and perhaps exceeds them slightly thanks to the thin atmosphere overhead. The band of light from billions of distant stars in our galaxy's disk appears as a distinct feature. A river of glow crossing from horizon to horizon through whichever constellations it traverses during the current season. Dark lanes of dust within the Milky Way are visible as silhouettes against the brighter background. Clouds of material that block light from more distant stars and create the patchy, complex texture the galaxy's band displays to naked eye observers. This is our home galaxy, seen from a slight different angle, nearly identical in appearance but witnessed from a world that offers less obstruction to the view. Meteors occasionally streak across the Martian sky, just as they do across Earth's, though the thin atmosphere means they do not burn up in the same dramatic fashion, familiar from meteor showers back home. Small particles entering the Martian atmosphere do produce some light from compression heating, but the brightness is less, the trails shorter, the display more subtle than the shooting stars that punctuate Earth's nights during peak activity periods. Larger objects that would burn up completely in Earth's atmosphere may survive to reach the Martian surface, their impacts cratering the landscape with fresh scars that add to the ancient record of bombardment visible everywhere on this world's surface. The sky here is not just a view but a source, delivering material from space more directly than Earth's thick atmosphere permits. The absence of light pollution makes the Martian night sky a treasure for any observer fortunate enough to witness it directly from the surface below. No cities glow on the horizon. No aircraft lights move among the stars. No satellites catch sunlight on their passage, though some might eventually orbit Mars in future decades of expanded exploration activity. The darkness is pure. The stars, uncountable to the naked eye. The universe presenting itself with a clarity that most Earth dwellers have never experienced, even in wilderness areas where artificial light seems absent. This sky alone would be worth the journey, a reward that accumulates each night the mission continues on the surface of this remarkable world. The practical work of the mission now takes precedence over pure exploration. The search for a suitable location where the first permanent base will be established for future inhabitants of this world. Scouting requires attention to factors that exploration could ignore. The difference between visiting a landscape and living in it, shaping every observation now taking place across the terrain near the landing site. The base must serve not just this mission, but generations that may follow, a foundation for permanent human presence on a world that offers no easy hospitality to biological life. Each potential site is evaluated against criteria that balance scientific interest, practical survival, and the long-term vision of what Mars settlement might eventually become. The first requirement is protection from the radiation that the thin atmosphere allows to reach the surface unimpeded throughout each sol and night, continuously. On Earth, the thick atmosphere and magnetic field combine to block most harmful radiation from space. Protecting life on the surface without any conscious effort required from the organisms benefiting from this shield. Mars lacks a global magnetic field and has only its thin atmosphere between the surface and the radiation environment of space, meaning cosmic rays and solar particles reach the ground at levels that would be problematic for long-term human health without additional protection. Natural shielding from terrain, hills, overhangs, even caves, if any exist nearby, becomes valuable in ways that would never matter on Earth. The crater wall to the east offers possibilities, a rising slope that could provide the back wall of a habitat built into the terrain, rather than standing fully exposed on the flat crater floor. Building partially into a hillside allows regolith to be piled over the structure more easily, creating a radiation shield from the material that is already present, without requiring transport of shielding mass from Earth at enormous expense. The slope also provides protection from prevailing winds that could carry dust against exposed surfaces. And it offers a psychological sense of enclosure that wide-open plains do not provide. The terrain here is stable, no signs of recent rockfall or slope instability that could threaten a structure built against the crater wall over decades of use. Water access is the second critical requirement. Unfortunately, the orbital data suggested ice deposits might exist within walking distance of this area when the landing site was originally selected, for exactly this reason. The ground-penetrating radar confirms what orbital observations implied, showing a layer of different density beginning about 1 meter below the surface, perhaps half a kilometer from the most promising construction site near the crater wall. This layer extends for a significant area and depth, representing potentially thousands of tons of water ice mixed with regolith, waiting to be excavated and processed into the water that makes long-term habitation possible. Without water, no base can sustain life for longer than the supplies brought from Earth. But with water, indefinite presence becomes feasible. Flat terrain nearby is necessary for landing resupply missions that will bring additional equipment, materials, and eventually people to expand what this mission establishes as a starting foundation. The crater floor near the selected site is encouragingly flat, a smooth area several hundred meters across that could accommodate multiple landing attempts without risk of setting down on slopes or boulder fields that would complicate surface contact for arriving vehicles. The delta provides a visual landmark for navigation. The crater rim provides reference points visible from altitude, and the overall site offers characteristics favorable for the repeated precision landings that sustained habitation requires. This is not just a good place for a base, but a good place for a small settlement to eventually grow around the initial structures established here. The view from the proposed site spans a significant portion of the crater floor, with the delta visible to the northwest and the crater rim rising to the east behind where the habitat would stand against the slope. The distance to the delta is walkable, making the most interesting geological feature in the area accessible for regular scientific investigation. Throughout the years of habitation that may follow this initial mission, the landing site where the spacecraft currently stands is also visible, about 2 kilometers to the southwest, close enough for the initial equipment to be transported by hand or small vehicles once they are assembled. The geography works, the pieces fitting together in ways that feel almost fortunate, given how many factors must align for a site to be suitable. The work of detailed site survey begins, walking the area with instruments that measure slope angle, soil density, surface stability, and other factors that will influence construction decisions in coming days. The ground here is firm enough to support structures without risk of settling or collapse. The regolith, compacted by billions of years of nothing disturbing it significantly since its formation from impact debris and wind-deposited dust. Some areas show signs of past dust devil activity, surface patterns indicating that rotating winds have passed through here. But these events are too weak in the thin atmosphere to threaten constructed habitats once they are in place. The site passes each test that field survey can provide. The overhang, where the crater wall has eroded unevenly, provides a natural shelter that could reduce the initial construction required to establish a protected space for early operations at this location. A structure built beneath this overhang would have rock above it from the start, requiring less regolith to be moved onto the roof for radiation shielding than a freestanding structure on the open plain would need to achieve the same protection level. The overhang is not deep enough to serve as the final habitat, but could protect equipment and personnel during the construction phase when permanent structures are being established nearby. This natural feature becomes part of the plan, an asset the terrain provides without human effort, beyond recognition of its value. The psychological aspects of base location matter more than purely engineering considerations might suggest. The mental health of inhabitants depending partly on the feeling of the place where they will spend months or years at a time. A site that feels too exposed might create anxiety over time, despite being technically safe from any real threats the environment poses to properly protected humans. A site that feels too enclosed might create claustrophobic reactions in people already living in small spaces with limited ability to simply step outside and breathe fresh air, as they could on Earth. This site balances these considerations, offering protection without imprisonment, views without vulnerability, a sense of place rather than just location. The shadows cast by the crater wall during different times of sol are evaluated, as the habit will need solar exposure for power generation and psychological well-being, while also benefiting from shade during the hottest parts of afternoon, when temperature management becomes more challenging. The proposed location receives direct sunlight for most of the sol, while having the option of shade available when desired, the rising terrain providing options rather than constraints as the seasons progress through the Martian year. Winter here will mean longer shadows and shorter periods of direct sun. But even in the darkest season, this site receives enough light to power solar panels and maintain the connection to the sun that human psychology seems to require for well-being over extended periods. Standing at the center of the proposed base site, you turn slowly, taking in the full circle of the horizon visible from this point that may become the center of human presence on Mars. The delta stands to the northwest, layered and patient, holding its ancient stories for future researchers to extract through careful examination of its sediments over years of detailed study. The crater rim rises to the east, a protective wall with geological interest of its own, visible in the exposed rock layers along its face. The landing site and spacecraft are visible to the southwest, a temporary foothold that will give way to permanent structures once the construction phase of this mission is complete. The crater floor extends to the west and south, flat terrain that offers expansion room if this base grows beyond its initial modest scale in future decades. This is a good place, perhaps not the only good place on Mars, but a genuinely suitable site for what must happen here. The return walk to the spacecraft passes through terrain that now feels familiar, rather than alien. The adjustment to Martian conditions, progressing faster than expected, despite the strangeness of this world compared to home. The rocks and dust and the pink sky above have become the context for normal activity rather than constant reminders of how far from Earth this mission has traveled to reach its destination. The base site is selected, the parameters confirmed, and the next phase of the mission can begin with the practical work of construction that will transform this surveyed location into humanity's first permanent foothold on another planet. Tomorrow, the work begins. The dust of Mars becomes impossible to ignore once attention turns from exploration toward the practical business of building something intended to last for years or decades in this environment. This fine, rust-colored powder covers everything on the surface, clinging to boots after each surface walk, accumulating on equipment left outside for even a single sole, infiltrating seals and filters, despite the best efforts of engineering to exclude it. The dust is not merely an annoyance, but a genuine concern for long-term operations, its properties creating challenges that Earth dust never poses because of the unique conditions under which Martian dust has formed over billions of years. Understanding this material becomes essential before construction can proceed safely and effectively at the selected base site. The particles that make up Martian dust are extraordinarily fine, averaging about 1.5 micrometers in diameter, smaller than the finest Earth dust, and approaching the size of particles that define smoke, rather than what we normally call dust. This fineness allows the material to remain suspended in the thin atmosphere for extended periods. After being disturbed, settling slowly in the weak gravity, while drifting sideways on the faintest breezes that occasionally stir the surface air. The same fineness allows the dust to infiltrate tiny gaps that larger particles would not enter, finding its way into equipment and habitats through openings too small to see without magnification. Every seal must be tested against this persistent ingress. The composition of the dust includes iron oxide minerals that give Mars its red color, the same rust that forms on iron exposed to oxygen and water on Earth created here through different processes over different timescales. Mixed with the iron oxide are salts called perchlorates, chemical compounds that pose particular concern for human health if allowed to contaminate living spaces where people breathe, eat, and sleep. Perchlorates can interfere with thyroid function when ingested even in small amounts, meaning the dust that covers everything outside cannot be allowed to contaminate the food, water, or air inside habitats designed for long-term human occupation. Decontamination procedures must be rigorous. The electrostatic properties of Martian dust create clinginess that seems almost malicious. Particles adhering to surfaces through electrical charge, rather than just settling under gravity and staying in place through weight alone. The dry conditions and the constant UV exposure create conditions where dust becomes charged, sticking to spacesuits, equipment panels, solar collectors, and anything else that presents a surface for attachment. Simple brushing does not remove this material effectively because the electrical attraction exceeds what gentle physical force can overcome without damage to delicate surfaces. Specialized cleaning methods, possibly including magnetic separation of the iron-rich particles, become necessary for maintaining equipment exposed to this persistent coating over time. The health implications extend beyond perchlorate contamination to include the physical effects of fine particles on respiratory systems if the dust is inhaled inside habitats where air is breathed without. Filtration. On Earth, we understand the dangers of fine particulate matter from pollution and mining, the way tiny particles can penetrate deep into lungs and cause inflammation that accumulates over years of exposure to create serious health problems. Martian dust would behave similarly if allowed into breathing air, its fineness, allowing it to reach the smallest airways, where the body has the least ability to clear foreign material through natural processes. Air filtration systems must remove particles to extremely high efficiency levels. The landscape shows evidence of dust everywhere, not just coating surfaces, but shaping them through millions of years of accumulation and movement, driven by winds that have blown continuously since Mars lost its water. Dunes of dust pile against obstacles on the downwind side, formed by the same processes that create sand dunes on Earth, but using material fine enough to behave differently in some respects. Dust drifts fill low areas and smooth out terrain over time, depositing meters of material in some locations while stripping it from others, where wind accelerates through gaps and carries its burden away. The surface geology reflects this constant redistribution, a slow-motion river of powder flowing across the planet without ever settling permanently. The experience of walking through this dust becomes familiar quickly, each step raising small puffs that drift away on breezes too faint to feel through the suit, but visible in the behavior of the suspended particles around your feet. The lower gravity means the dust rises higher and falls slower than it would on Earth, creating momentary clouds that hang in the air for seconds after each footfall before dissipating into the thin atmosphere. The path you have walked becomes visible from a distance as a slightly darker line where the surface dust has been disturbed, footprints remaining crisp for days or weeks because nothing but more dust will ever alter them. You are writing a record of movement in the dust that will preserve your passage for years. Dust storms represent the most dramatic manifestation of this material's behavior. Events that can grow from local disturbances to planet-encircling phenomena that reshape the conditions on the entire world for months at a time. These storms begin when surface heating creates strong enough convection to lift dust high into the atmosphere, where it spreads and absorbs more sunlight, creating additional heating that lifts more dust in a feedback cycle that can escalate rapidly under favorable conditions. Once established, a global dust storm can persist for weeks or months as the dust slowly settles out of the atmosphere, only to be lifted again by continuing winds. Solar power becomes unreliable during these events. Visibility drops to near zero, and everything exposed accumulates thick coatings of material. The preparation for dust management begins with the airlock design that will prevent most contamination from entering the habitat, where people will live without their protective suits during occupation. The airlock includes a space where suits can be removed and stored, keeping the contaminated outer garments separate from the clean interior environment, where food preparation and sleeping and all the vulnerable activities of human life will occur. Brushes and vacuums help remove loose material before entering, but the electrostatic cling requires additional treatment, perhaps air jets, or ultrasonic cleaning, or careful wiping with dampened cloths that carry away the charged particles more effectively than dry removal methods can achieve. The solar panels that will power the base must be designed for regular cleaning, their surfaces accessible, and their materials resistant to the abrasion that dust removal will inevitably cause over repeated maintenance cycles. The dust reduces power output significantly when allowed to accumulate. As the Opportunity rover demonstrated during its 15-year mission before a global dust storm finally blocked enough light to end its solar-powered operations permanently. Wind occasionally cleans panels naturally, and some designs include coatings that reduce dust adhesion. But regular human maintenance will likely be necessary to maintain reliable power output at levels sufficient for life support and operations. This is a chore that Martian settlers will perform weekly or even daily. The dust becomes a companion of sorts, always present, always requiring attention, always a factor in every activity undertaken on this world, during the mission, and presumably forever after. Learning to live with this material is part of learning to live on Mars, an accommodation to conditions that cannot be changed and must instead be managed with appropriate technology, procedures, and attitudes. The dust was here before we came, and will be here long after we leave, indifferent to our presence, following the winds that have blown across this world since the atmosphere existed to carry it. We build within the dust, through the dust, despite the dust. The selected base site shows no special susceptibility to dust accumulation compared to other locations in the crater. The terrain neither funneling material toward it nor unusually exposed to wind-driven deposition from any particular direction. This is reassuring for construction planning, because building in a location that naturally accumulates excessive dust would create problems beyond the baseline challenges that dust presents everywhere on the Martian surface. The site is neither better nor worse than average, and average is manageable with the equipment and procedures that have been developed through years of planning for exactly these conditions. The dust will be present, but it will not dominate. Water becomes the central concern as planning advances beyond site selection toward the actual logistics of sustained human presence in this environment. Without water, no base can last longer than the supplies brought from Earth, a fundamental limitation that would make permanent settlement impossible, regardless of any other factors favoring a particular location. With water, everything changes. Drinking, sanitation, agriculture, air production, even fuel manufacturing, all become possible using local resources that need not be launched across interplanetary space at enormous cost. The discovery of accessible water ice near the base site transforms the mission from a temporary expedition into the foundation for something lasting and expandable over time. The water ice on Mars exists in several forms, distributed across the planet in patterns that reflect billions of years of climatic history and the physics of volatile behavior in thin atmospheres and cold temperatures. The polar caps contain most of the planet's known water, massive deposits of ice mixed with carbon dioxide frost that grow and shrink with the seasons at high latitudes. At lower latitudes, water ice exists beneath the surface, protected from sublimation by the layer of dry regolith above it, detected by radar from orbit and confirmed by landers that have directly observed ice-rich material exposed in trenches and impact craters. The deposits near Jezero Crater fall into this last category, subsurface ice waiting to be excavated by the first human settlers to reach this location. The ground-penetrating radar carried on this mission confirms what orbital surveys suggested. a distinct reflective layer beginning about 1 meter below the surface in an area approximately half a kilometer from the chosen base site. This layer likely represents ice-rich regolith, soil containing perhaps 20 to 30% water ice, by mass mixed with the rock and dust that make up the bulk of the material. Extracting water from this mix will require digging to reach the ice-bearing layer, then heating the material to sublimate the ice into vapor that can be collected and condensed back into liquid water for use. The process is straightforward in principle, but requires energy and equipment that must function reliably in conditions far from any supply chain. The excavation of a test pit begins as part of the mission's water verification activities, digging through the surface regolith to reach the depth where ice should be present if the radar data has been interpreted correctly. The digging is slow work in the suited environment, each shovelful of soil requiring more effort than it would on Earth, despite the lower gravity, because the suit constrains movement and the muscles are still adapting to working in Martian conditions. The rust-colored surface material gives way to darker soil below, the color change suggesting composition differences that match expectations for ice-bearing regolith compared to the dry overburden above it. Progress continues downward. The first sign of ice appears at 80 centimeters depth, the soil color changing again to a grayish-blue tint that looks almost damp, though no liquid water can exist here under these pressure and temperature conditions. This apparent wetness is actually fine ice particles mixed with the regolith, the ice sublimating slightly at the exposed surface, but remaining stable below where fresh excavation has not yet disturbed it. A sample brought into the spacecraft and allowed to warm confirms the presence of water. Liquid actually beads on the surface of the material as temperatures rise above freezing inside the pressurized cabin. Clear drops of water emerging from Martian soil for the first time under human observation, directly. Water is here, accessible, sufficient. The quantity of ice in this deposit exceeds what any single mission could use, likely containing thousands of tons of water ice within the volume that the radar signature suggests lies beneath the surface in this area. This abundance means the base can operate indefinitely with local water supply once extraction equipment is operational. And it means excess water can be used for purposes beyond basic survival, growing food in eventual greenhouses, producing oxygen for breathing through electrolysis, even manufacturing rocket fuel by splitting water into hydrogen and oxygen components. The water deposit is not just survival insurance, but an economic foundation for everything else the base might eventually do on this world. The extraction system design calls for heating regolith inside a sealed vessel, capturing the water vapor that sublimes from the ice, and condensing it back to liquid for storage in insulated tanks, protected from the cold that would refreeze the precious resource if allowed to reach it. Solar energy can provide the heat needed for this process, concentrated by mirrors or converted to electricity, and fed to heating elements depending on which approach proves more practical in the field. The process will operate continuously once established, extracting water faster than the base consumes it, building reserves that provide security against equipment failures or unexpected consumption spikes. Redundancy and reserves make the difference between survival and failure. The presence of water answers the most fundamental question about whether permanent habitation is possible here. But it also opens questions about the water's history and what it might contain from the period when Mars was warmer and wetter than today. This water ice is ancient, potentially billions of years old, frozen during the transition from wet Mars to dry Mars, and preserved beneath the protective regolith layer ever since that dramatic climate shift. If life ever existed on Mars, traces of it might be preserved in this ice. Organic molecules, chemical signatures, perhaps even microbial cells frozen in place when the water they inhabited turned to ice. Scientific examination of the ice becomes as important as practical extraction. The water on Mars connects to the water throughout the solar system, a reminder that this precious substance is not rare in cosmic terms, even though it is concentrated in certain locations, like this deposit near the base site. Water ice exists on the Moon, on asteroids, on comets, on the moons of Jupiter and Saturn, even on Mercury in permanently shadowed craters near the poles where temperatures remain cold enough to preserve it. Mars is particularly rich in accessible water compared to the Moon, one of the factors that makes it favorable for settlement, despite the greater difficulty of reaching it from Earth compared to our nearer neighbor. Water is the key to living beyond Earth. The tanks that will store extracted water are among the equipment brought from Earth in previous cargo missions, waiting at the landing site for transport to the base location once construction there reaches the phase where water handling systems can be installed and tested. These tanks are insulated to maintain liquid water in an environment that would freeze it solid within hours if left unprotected against the Martian cold. Heating elements powered by the base electrical system maintain temperature above freezing, a constant energy cost that must be factored into the overall power budget of the settlement. Water management becomes central to all planning. The psychological effect of confirmed water access exceeds its practical importance. A sense of security settling over the mission now that this fundamental resource is known to be present in usable quantity nearby. The difference between hoping for water and knowing water exists is the difference between optimistic planning and confident execution of the base establishment activities that fill the remaining days of this mission. The future inhabitants of this base will not struggle for water, will not ration every drop anxiously, will not face the constant uncertainty of depending entirely on resupply from a planet that is sometimes months of travel away. They will have what they need, right here. The construction phase begins with clearing and preparation of the ground where the first habitat module will stand, a foundation that must be level and stable enough to support structures intended to last for decades in this environment. The tools for this work are simple. By Earth standards, shovels, rakes, compactors, measuring devices, but using them here requires adaptation to suits and lower gravity and the fine dust that coats everything within minutes of beginning any surface disturbance. Progress is slow compared to Earth construction, but every centimeter of prepared ground represents permanent change to the Martian surface, the first intentional reshaping of terrain for human habitation beyond our home world. The foundation area is marked with stakes and lines, creating a visible boundary that defines where the first structure will stand once the preparation work is complete, and assembly can begin in the days ahead. The ground within this boundary must be cleared of larger rocks and smoothed to a tolerance of just a few centimeters across the entire footprint. Requirements that take time to achieve with hand tools and limited mechanical assistance. Each rock removed reveals the soil beneath, the reddish dust giving way to darker regolith that has not seen the sun since it was buried by later deposits untold years ago. The work is physical and rhythmic, the kind of labor that occupies the body while the mind drifts. The rhythm of construction work creates its own meditation, the repetitive motions becoming automatic, while attention settles into a quiet, observational state that notices the landscape without actively studying it. The sun moves across the pink sky as hours pass, shadows shifting around the work site, the temperature rising toward afternoon highs that remain far below freezing but feel warm compared to the overnight cold that will return after sunset. The crater rim stands to the east, unchanged by any of this activity, the same patient presence it has maintained for billions of years before this moment, and will maintain for billions of years after. Small human effort against the backdrop of geological time. The prefabricated habitat modules that will become the first structures arrived in earlier cargo missions, waiting in their protective containers at the landing site for the day when humans would arrive to assemble them into livable spaces. These modules are compact for transport, but expandable once deployed, their walls and floors unfolding from packed configurations into volumes large enough for human occupation without oppressive confinement. The technology draws from decades of space station experience, habitat designs tested in orbit and on Earth, refined for the specific conditions of Mars where atmospheric pressure is negligible, but gravity is present, unlike the weightless environment of orbital stations. The first module is transported from the landing site to the prepared foundation, a journey of 2 kilometers that takes most of a day, using the small transport vehicle assembled from components brought along specifically for moving heavy equipment across the Martian surface. The module rests on its skids, sliding across the dusty ground as the vehicle pulls it slowly toward its permanent location, leaving parallel tracks in the surface that mark the path of this historic movement. Upon arrival at the base site, the module is positioned precisely on the prepared foundation, aligned with the stakes and lines that mark its intended footprint, ready for the deployment sequence that will transform it from a compact package into a habitable structure. The deployment process takes several hours, systems activating in sequence as the module's walls extend and lock into position, its floor panels unfolding to create living space, its roof sections sealing together to form the pressure boundary that will separate inside from outside. Monitoring displays show the progress in real time, each structural element confirming its proper position, each seal reporting its integrity. The whole assembly achieving final configuration as the afternoon light fades toward the evening that will see this structure stand complete for the first time. When deployment finishes, a pressurized space exists on Mars. Small, empty, unfurnished, but real. The first pressurization test begins immediately. Air pumped into the sealed structure from tanks brought along for exactly this purpose. Pressure rising slowly while sensors monitor for any leakage that would indicate seal failure, requiring repair before the habitat can be trusted with human life. The pressure rises, holds, continues to hold as hours pass without significant loss, the structure demonstrating the integrity that will keep its inhabitants alive in an environment that would kill unprotected humans in moments. The test is complete, the habitat is ready, and for the first time in human history, a pressurized structure stands on the surface of Mars, built by human hands for human occupation. The interior of the habitat is bare at first, just walls and floor and ceiling forming an enclosed volume, perhaps 8 meters long and 4 meters wide. Enough space for basic living functions without luxury or spaciousness. Equipment installation will follow. Life support systems, power distribution, communication gear, furniture for sleeping and eating and working. All the details that transform a pressurized volume into a place where humans can actually live for extended periods. But for now, just the existence of this space is enough. A proof of concept that establishes the possibility of everything that will follow in future missions and future years. Stepping inside for the first time, after removing the helmet in the verified atmosphere, you breathe air that smells of new materials and recycled gases. The particular scent of a spacecraft interior that has become familiar during the journey here. The walls curve slightly overhead, the structure designed to distribute pressure loads efficiently, and the small windows offer views of the rust-colored landscape outside, now visible without the intervening helmet that has mediated all previous views. This is indoors on Mars, a small bubble of Earth-normal conditions on a world that offers no such conditions naturally anywhere on its frozen, airless surface. The achievement is quiet but profound. The remaining days of the mission will see additional modules deployed and connected, the base growing from a single pressurized unit into a small complex with specialized spaces for different functions. Life support equipment will be installed and tested, proving the systems that will keep future inhabitants alive during extended stays. Power systems will be connected, solar panels and possibly nuclear generators, establishing the electrical foundation that everything else depends upon for continuous operation. Communication systems will link this outpost to Earth, enabling the coordination with home that makes any endeavor beyond Earth possible. Piece by piece, the base comes into existence. The sunset, visible through the habitat window, is the first sunset watched from inside a human-built structure on Mars. The blue glow around the descending sun, painting the sky with colors that seem impossible to eyes trained on Earth. You watch it from within a warm, pressurized space, comfortable without a suit for the first time in days, experiencing this moment in a way no human has experienced any Martian sunset before this evening. The window frames a view that future inhabitants will see countless times. But this first viewing carries the weight of history, the awareness that something new has begun here that cannot be undone. The base is taking shape, but the vastness of Mars beyond its boundaries reminds every glance outward of how much remains unexplored, how much lies beyond the horizon that cannot be reached during this first short mission. The great features of this world are not visible from Jezero Crater, not even the nearest of them. But knowing they exist on the same planet where you now stand changes the feeling of the landscape, even when viewing only the local terrain. Olympus Mons rises somewhere to the west, the largest volcano in the solar system, its summit more than 20 kilometers above the surrounding plains. Valles Marineris stretches across the equatorial regions, a canyon system so vast it could span the United States from coast to coast. These features wait for future explorers. Olympus Mons cannot be seen from here, but its scale can be contemplated using known measurements that convey its immensity through numbers, even when direct observation is impossible from this distance and location. The mountain rises 22 kilometers above the reference surface of Mars. nearly 3 times the height of Mount Everest above sea level on Earth. The base of the volcano spans over 600 kilometers, large enough that an observer standing at its edge would not be able to see the summit above the horizon, because the mountain's own breadth would curve away below the summit out of view. This is a volcano so large that it does not look like a mountain at all from ground level, just an infinite gentle slope stretching upward forever. The height of Olympus Mons reflects the absence of plate tectonics on Mars, the process that on Earth moves volcanic hotspots away from their magma sources and limits how large any single volcano can grow before its supply is cut off. On Mars, the hotspot that fed Olympus Mons remained in place for billions of years, lava flowing repeatedly from the same source, building layer upon layer until the structure reached dimensions that have no parallel anywhere else in the known solar system. The volcano is now dormant, perhaps extinct, its last eruptions occurring millions of years ago based on the crater counts that date Martian surfaces. But the mountain remains, patient and enormous. Valles Marineris is equally beyond human experience in its scale. A canyon system stretching over 4,000 kilometers across the Martian surface, in some places reaching 7 kilometers deep and 200 kilometers wide. If placed on Earth, this canyon would stretch from New York to Los Angeles, its depth greater than any ocean trench, its width greater than any geological feature our planet possesses, except the great oceanic basins themselves. Standing at the rim of Valles Marineris, you would look out at the opposite wall, visible only as a faint line on the horizon across the gulf of distance. The floor of the canyon invisible below, and perhaps hidden beneath atmospheric haze. The origin of Valles Marineris remains debated among scientists, with leading theories suggesting it formed as a massive crack in the Martian crust during the rise of the Tharsis volcanic bulge to the west. The upwelling of magma, stretching and splitting the surface above it. Subsequent erosion, possibly including water and ice, widened and deepened the initial fracture into the enormous canyon system visible today from orbit and in maps derived from decades of robotic exploration. The walls of the canyon expose layers of rock spanning billions of years of Martian history, a geological record that would take lifetimes to fully examine and understand in detail through future expedition work. The Tharsis region, where these great features are concentrated, represents a unique concentration of volcanic activity that reshaped this hemisphere of Mars during the early solar system. 3 additional massive volcanoes line up southwest of Olympus Mons, each one comparable in size to the largest volcanoes on Earth, though dwarfed by their neighbor to the northeast. The entire region sits on a bulge in the Martian crust, elevated several kilometers above the reference surface, the result of mantle upwelling that persisted long enough to create these monuments to internal planetary heat. Mars was not always the cold, quiet world it is today. The contrast between these distant features and the modest terrain visible from the base site highlights the diversity of Mars, a world not uniform in its geography, but varied in ways that rival Earth, despite the absence of oceans and vegetation that define so much of Earth's visible character. Jezero Crater is interesting for its ancient lake history and the delta that records water flowing here billions of years ago. But it is a subtle feature compared to the dramatic landforms visible elsewhere on this world. The future of Mars exploration will eventually reach these distant places, But that future begins here, with this base, with these first steps toward permanent presence. Hellas Basin lies in the southern hemisphere, an impact crater over 2,000 kilometers wide and 8 kilometers deep, the lowest point on the Martian surface, where atmospheric pressure is highest and conditions most closely approach what might eventually support some forms of life or industry. The northern lowlands stretch across nearly half the planet, a relatively smooth plain that some scientists believe once held an ocean during the wet period of Martian history, when water was abundant on the surface. These features represent futures beyond futures, destinations for expeditions that will not begin for decades or centuries. But all of it starts with the presence being established here. The polar caps would show seasonal variation if they could be observed from here. The southern cap shrinking dramatically during southern summer, while the northern cap maintains more stability through its annual cycle. These ice caps contain most of the water known to exist on Mars, frozen reservoirs that might someday be tapped for resources if the challenges of polar operations can be overcome through technology not yet developed. The caps also contain frozen CO2, dry ice that sublimates directly to gas when conditions warm, creating phenomena unlike anything on Earth, where carbon dioxide never freezes naturally at surface conditions. The global perspective settles into the local reality of the base site, the understanding that this small foothold connects to all those distant features through the shared world they all occupy. Future inhabitants of this base may eventually mount expeditions to some of those places. Journeys that would take weeks or months using vehicles not yet designed or built for Martian surface travel over such distances. For now, the few kilometers around the base represent the entire accessible world, a tiny fraction of the whole, but enough to begin the process that will eventually make all of Mars reachable by the humans who will follow where this mission has led. The evening comes again, another sol drawing to its close, another blue sunset painting the western sky, with colors that still surprise despite growing familiarity. The base stands more complete now than yesterday, another module connected, another system tested and found working. The settlement gradually becoming capable of supporting the life it was built to shelter. Tomorrow, more work, more progress, more permanent change to this world that has waited so long for company. The distant giants will continue waiting, patient as they have been for billions of years, knowing nothing of time or expectation or readiness. The base has grown beyond a single module now. 3 pressurized units connected by short tunnels that allow passage without suiting up, creating a complex with differentiated spaces for living, working, and managing the systems that keep everything functioning properly. The life support equipment fills most of one module, the air recycling systems and water processing units and thermal regulation equipment that together maintain Earth-like conditions inside this small pocket of habitability on a world that offers no hospitality to unprotected human life. The hum of these machines becomes background noise, ever present and eventually unnoticed, the sound of survival itself translated into mechanical rhythm. The power systems are operational now. Solar panels spread across a cleared area near the base, their dark surfaces tilted to catch the Martian sun at optimal angles throughout the sol. The output is lower than the same panels would produce on Earth. The greater distance from the sun reducing solar intensity to about 43% of what we receive back home. But the array is sized to compensate for this reduction. and still provide adequate power for basic operations. Battery storage handles the night hours when no solar input is available. The system cycling between collection and consumption in a rhythm that matches the soul's light and dark periods automatically. Power is life here, and power is secure. The interior of the living module has been equipped now. Sleeping quarters and a small galley, and a workspace with communication equipment linking this outpost to Earth across the gulf of space that separates the two worlds. The furnishings are minimal but functional. Every item chosen for necessity rather than comfort, though some small personal touches have been added where space and weight allowances permitted during mission planning back on Earth. A photograph, a small plant experiment, a notebook, traces of individual humanity amid the standardized equipment that fills most of the available space throughout the connected structures. Walking through the base without a suit feels strange and wonderful simultaneously. The freedom of movement contrasting sharply with the restricted motion that surface activities require in the protective garments that separate human flesh from Martian conditions outside. Inside, you can reach, bend, twist, move in ways the suit prevents, your body remembering how it prefers to exist when not encased in protective layers. The temperature is comfortable, the air is breathable, the pressure is normal. All the conditions that make existence effortless on Earth have been recreated here through engineering rather than nature. Artificial normalcy in an environment that would destroy unprotected human life in moments. The view through the windows has become familiar now. The rust-colored terrain and salmon pink sky, visible from inside without the helmet framing, that characterized all earlier observations during surface activities. The crater rim rises to the east, the same patient presence it has maintained throughout the mission, the same geological feature that will stand here long after this base has crumbled and been reclaimed by the dust that covers everything eventually. The window glass is layered for protection against micrometeorites and radiation, slightly distorting the view, but not enough to diminish the impact of looking out at an alien world from inside a space that feels almost domestic. The communication delay with Earth has become part of the mission's rhythm. Questions sent homeward and answers arriving hours later, depending on the current orbital geometry that determines distance and therefore signal travel time. Conversations are impossible in the traditional sense, replaced by careful exchange of information packets that must anticipate questions and provide context without real-time clarification available. The delay creates a particular kind of self-reliance, the knowledge that any emergency must be handled locally because Earth's assistance would arrive too late to matter in most scenarios. This outpost operates with the autonomy that Earth-based facilities never require. The dust has accumulated on everything exposed outside, coating the solar panels until cleaning restored their output, settling on equipment housings, drifting against the base walls in small ridges that will grow larger as souls pass without disturbance. The reddish powder has found its way into the airlock. Despite precautions, fine particles tracking inside on suits and equipment, requiring periodic cleaning of the transition spaces to maintain separation between the contaminated exterior and the protected interior. Dust management has become routine, another chore in the cycle of activities that maintain the base as a functioning system. The sense of home has begun to attach to this place, Despite its small size and its isolation on a world where no other human presence exists, within tens of millions of kilometers. Home is not just a location, but a relationship. A place where routines develop and comfort accumulates through familiarity and the small personalizations that make a space feel occupied rather than merely visited. This base is becoming home for the duration of this mission, and it will become home for others who follow, each adding their own traces to the space that future inhabitants will occupy. The work remaining before departure is mostly documentation and testing, ensuring that the systems left behind will continue functioning without human intervention for however long passes before the next crew arrives to occupy and expand what has been established here during these foundational days. The life support systems can operate autonomously for extended periods. The power systems are designed for long-term reliability. The structures are built to withstand the temperature cycles and radiation exposure that will continue sol after sol, regardless of human presence. The base will wait, patient as Mars itself. The accomplishment settles into full awareness as the final systems are checked and the departure countdown begins in the background of daily activities. What was theoretical planning back on Earth has become physical reality here. Structures standing on Martian soil, systems functioning as designed, human presence proven possible not just in theory, but in fact. The first chapter of human Mars habitation is complete, and nothing can undo what has been done here. The next chapters belong to others. The stars appear outside the window as night falls again over the base. The familiar constellations turning slowly above a world that now holds something new beneath their ancient light. Earth is there among them, visible if you know where to look, blue and white, and impossibly far away, yet somehow still home, despite everything that has happened since leaving its surface months ago. Two worlds now, two places where humans live and work and plan for futures that span solar system scales. The night is quiet around the base. The final day of surface operations arrives with a sunrise, like all the others that preceded it. The eastern sky, lightening through purple to pink as the small sun climbs towards visibility, and another sol begins its measured unfolding. This will be the last sunrise watched from this place during this mission, though not the last sunrise anyone will ever watch from here. Others will come, will see what you have seen, will add their experiences to the history of human presence that begins with these days. The morning light falls on the base the same way it fell yesterday and the sol before, indifferent to human schedules and departures and the meanings we attach to particular moments. The final walk around the base site takes longer than practical necessity requires, attention lingering on details that have become familiar over the preceding days of work and exploration. The delta stands in the distance, its layered face visible from here, the ancient stories it holds still waiting for the detailed examination that future researchers will provide over years of extended study. The crater rim rises to the east, patient as always, the same boundary it has provided for billions of years, continuing to define this space as distinct from the plains beyond. The landing site is visible to the southwest, the original spacecraft waiting there for the return journey that will begin soon. Earth appears in the morning sky, low in the east ahead of the rising sun, a blue-white point of light, brighter than most stars and carrying colors that no star matches. Everyone who has ever existed, except for you, in this moment, lives on that small point, going about their days without direct awareness of your observation from this unprecedented vantage point across the gulf of space. The distance seems less overwhelming now than it did at the beginning of this journey, familiarity reducing what once felt impossibly vast into something more like a very long commute home. Earth is there, waiting, the same world it has always been, despite everything that has changed. The base stands complete behind you as you look outward across the landscape, one final time before the departure preparations claim your remaining hours. 3 modules connected, systems operational, supplies stored for whoever arrives next to continue what began here during these foundational days. The structure looks small against the vastness of the crater floor, tiny compared to the features visible from orbit, insignificant against the scale of geological time that Mars represents. But it is real, it exists, it works, and nothing can diminish the fact that humans built this place and will return to live here. The footprints you leave walking back toward the landing site will remain visible for years, perhaps decades. The slow accumulation of dust eventually filling them, but not before many Martian seasons have passed. Other footprints will follow, other boots pressing different patterns into the rust-colored soil. But these first prints will always have been first, even when they are no longer distinguishable from the general surface. The record exists in memory, in data, in photographs sent home during the mission that are now stored in archives on Earth, where they will survive longer than any physical trace here can endure. The spacecraft that will carry you home stands where it landed days ago, its surfaces now coated in the fine dust that covers everything exposed to the Martian atmosphere for any length of time. Systems have been checked, fuel is sufficient, trajectory calculations have been verified multiple times by teams on 2 worlds working together across the communication delay. The departure is routine in some ways, similar to countless mission conclusions in the history of spaceflight, but unique in one fundamental way that changes everything about what it means. Lifting off from Mars, watching the surface fall away below, as the engines carry the spacecraft up through the thin atmosphere toward orbital space. The base becomes visible from above as a small cluster of structures amid the vast emptiness of the crater floor surrounding it. The delta appears, then the full extent of Jezero Crater comes into view. As altitude increases, the curved rim defining the basin, where an ancient lake once held water, deeper than many Earth lakes today. The view expands, more terrain becoming visible, features recognizable from maps studied during training months, and years ago now seen directly from above, with human eyes for the first time. The orbit stabilizes, Mars rotating below, as systems prepare for the transit back to Earth. That will take months of patient coasting through the emptiness between worlds. From this vantage point, the planet looks small enough to hold in your hands, a rust-colored marble against the black backdrop of space. The same view that orbiting spacecraft have returned through photographs that inspired the journeys, now becoming reality. But photographs cannot convey the full experience of watching a world turn beneath you, knowing you walked on its surface, left your mark on its ancient dust, built something that remains behind as you depart. The journey home will be long and quiet. Months of coasting between worlds, with nothing to do but wait and maintain the systems that keep the spacecraft functioning and its passengers alive. The excitement of arrival fades into the routine of transit, the extraordinary becoming ordinary through simple duration and repetition of the mundane tasks that fill each day, regardless of location. But something has changed that cannot be unchanged, an experience that will remain part of everyone who participated in it for the rest of their lives and beyond. Mars shrinks in the window over the following days, the disk that filled the view during arrival and landing becoming a smaller circle, then a point, then just another bright object among the stars that fill the space between worlds. The base is no longer visible, too small to detect from this distance, but its existence continues regardless of observation. Systems hum, power flows, the habitat waits, all of it persisting through the empty sols, while the distance between you and it grows larger with each passing hour. Earth grows brighter ahead, still months away but already the dominant destination, the conclusion that pulls the trajectory forward through the emptiness toward arrival and return. The blue-white point that was visible from the Martian surface becomes more clearly a world, then a disk, then eventually a sphere with visible features. The progression, reversing what happened on approach to Mars so many months ago. Home comes back into view, changed perhaps by the perspective gained during absence. Familiar, yet different, now that you know what lies beyond. The night sky from Mars remains in memory, the blue sunsets and the racing moon, and the stars that seem steadier than any Earth sky has ever shown them. The dust remains on some equipment despite cleaning fine particles that traveled between worlds as passengers on the surfaces that carried them. The experience integrates into identity, becoming part of how you understand what humans are capable of and what might come next as the species continues expanding outward from its birth world toward whatever futures await. The base waits on Mars, empty but functional, ready for whoever comes next to build upon what began during these first days of human presence on another world. The dust settles slowly around its walls, the seasons turn, the stars wheel overhead in patterns that continue regardless of observation. Mars has been changed by human presence, and that presence will return, and eventually it will stay, and eventually Mars will become what Earth has been, a home for the species that needed more space than one world could provide. The story that began here continues, somewhere between the red planet and the blue one, somewhere in the space where futures are still being written.